started. We are going to talk about our first data structure, abstract data structure today, which is the list structure. Okay. I would like to check meeting chat for that as well. Okay, let me share my screen. This one. You are able to see my screen right now, right?
Yes, sir.
Okay. Okay. Now it's in presentation mode. Everything is set, so we can start. Okay. Today we are gonna, as I said, we are gonna talk about our first abstract data type, which is list data type. List is one of the most basic abstract data types. Probably you all know list structure before. It keeps the elements sequentially, as you all know. And where am I? Okay. Okay. And we are going to talk about the Java implementation of list structure. In Java, there's a list interface, and there are several implementations of this list interface. One of them is array-based implementation of list, array list, and another one is vector and linked list, as you all know probably. We are going to talk about these implementations. Actually, we are going to talk about Java's collection framework. And in this collection hierarchy, we are going to see the interface and the implementations of this interface. Also, we are going to talk about how to implement these data structure by ourselves. So we are going to implement the list interface in Java by using arrays, simple basic arrays, and linked list, connected list of nodes structures, okay? And we are going to compare and contrast these two implementations performance in time. Okay, these are the topics we are going to cover in this chapter, and I'm going to start with the list structure. In list structure, it's a sequential structure. It contains collection of elements, and each element in this collection has a position or index that you can use to access the element. Also, there is an iterator. You all know the iterators, right? There is an iterator that helps us to access the elements one by one from the beginning to end without using index structure. Okay. Also, we are going to talk about several implementations of it. As I said, in Java, we have array list, vector, and linked list. We are going to talk about them. And in Java, all of these implements list interface, but not directly implement list interface. There is a abstract list between them, which helps our implementations. and abstract list collects the common information about these implementations so that the implementation is not repeated. It facilitates code reuse and makes our lives easier. Okay, what is list abstract data type? And it's in Java terminology, its counterpart list interface. As I said, Java provides a list interface in Java util, and this list interface provides several functionality in list abstract data type. For example, we can obtain an element at a specified position. This position is specified by an index value, an integer. So you give an integer value and obtain the element in that position. You can replace a specified position, right? Do you remember the methods that implements these operations? For example, what's the method to implement obtain an element at a specified position? How can we obtain an element at a specified position in Java? Java's list interface. What is the name of the function method? Yes, someone. What's the name of the method for this operation? Don't you remember?
Maybe
Come on.
get.
Get. Get method gets an element at a specified position, right? It gets an index. It takes an index as a parameter and returns the element. Okay. What about replacing the value? What is the method to perform this operation?
Set, I think.
Replace.
Set, right? That's right. And find a specified target value.
Get. Oh,
Get
yeah.
gets a position and returns the value. In this operation, you have to specify the element and get its position.
Index of.
Yes, index of. Right. Add an element at either end. Actually, there is a method to add an element at the end, which is add, right? To remove an element from the end, we have remove, right? And to insert an element at an end position, we have another add method, overloaded add method. And to remove an element from any position, we have a overloaded remove method, right? What about the last entry? Traverse the list without managing a subscript. What do we use for this operation? Each class in collection hierarchy, each abstract data type in collection hierarchy contains some structure. What's that?
Iterator.
Iterator, right? So we can traverse the list structure without managing a subscript using iterator. So the list interface or array list contains a method iterator that returns an iterator class instance. So you can use that iterator class instance to iterate through the list interface, right? So this list of operations specifies the list abstract data type. And in Java, we have these operations in list interface to handle list abstract data type. Okay, abstract data type is a general notion, and in Java we have interfaces that kind of implements this notion. Okay. Okay, this is the list interface. This is the some small portion of collection framework. As I said, we have talked about Java collection framework, collection hierarchy in this class. There are several different data types data structures are implemented in collections framework. This is a part of it, some small portion of it, a small portion of collections hierarchy. We have a list interface that contains the definition, declaration of these methods, right? And there is an abstract list that implements the list interface, but of course it's not a concrete class. It's an abstract class, leaves several methods to its subclasses. Array list, vector, and linked list are the three implementations of abstract list. Right now, I'm not going to talk about these two. They are available, but probably needs to specify abstract sequential list. Abstract sequential list extends the abstract list and puts some more functionality to be able to get the advantages of linked list. Linked list, we are gonna see there are some advantages of it, and to be able to use up these advantages, we extend the list defined in list interface by sequential list abstract class. Okay. Today we are going to talk about list interface, abstract list a little bit, and mostly array list. Okay. As I said, list interface contains the declaration of these methods. In here, this is a subset of the methods in list interface. List interface have more methods than these. You can check out the Java specification on the web probably to see the methods, all the methods in list interface. This is a simple set of these methods. Okay, so the question here is, we have several implementations here, right? We have array list, vector, and linked list. Which one we are gonna use? Which one is the best for us? How we are gonna decide on this? How are we gonna make engineering of it? Means that engineers should choose the best alternative between several different alternatives. We have three alternatives for the list interface. which one we are gonna pick, and how we are gonna decide which one to pick.
Efficiency.
Efficiency means what? Efficiency of what? Efficiency is, as a general term, it can be energy efficiency, right? We talk about energy efficiency lately a lot, and efficiency of use of our water is important these days. Water is a very scarce resource, right? In Istanbul, at least, we are very limited water resources, and we have to use it efficiently. So efficiency can be used for many places. What efficiency? What kind of efficiency is important here?
Time efficiency.
Time efficiency. Time efficiency is important. What do we mean by time efficiency?
Maybe about searching, for example, which I remember linked list takes more time according to the array list, because we cannot reach the elements using index.
For example, you are talking about get method, right?
Yeah.
In get method, if we are gonna use the get method a lot, the time efficiency of the get method is important for us, right?
Yeah.
Time efficiency means how long it takes when I call get method to return, right? And how we are gonna measure the time efficiency is important. How we are gonna measure? We can measure it by using our clock, right? Stopwatch. We press the button of our stopwatch when we start the get method, and when it returns, we stop the stopwatch and check the running time, right? In seconds. We can calculate the exact running time of the get operation that we use. But if we have 100 elements in our list, if I try to get the first element, the index 0 element in array list, how long does it take? Probably very small time, right? It will return right away, since it uses the index to access the value. Since it is array based, in arrays we can access the elements right away. In linked list, again, the accessing the first element is quite fast, right? And when we compare the running times, it looks very similar, probably. The running time for accessing the first element in the list would be same for array list and linked list. What about accessing the element in the middle? Element 50. In array list, accessing element 0 or element 50
It doesn't matter.
Would take the same amount of time, right? Yeah. What about array linked list? It should traverse through the fifth element. For example, let's say this is the fifth element. Let me put some dots here. It should traverse through all the elements until the fifth element. It will take a lot of more time than array. How are we gonna measure then? I mean, searching the first element will be fast for both, and searching 50th element takes longer time in linked list. How are we going to compare based on the based on searching the 15th element or first element? How are we going to compare? In this case, we are going to talk about worst case behavior of the running time. What is the worst case? In array, searching any of the elements would take similar time, so the worst case is same for all the elements. But for the linked list, searching for the last element would take the longest time if you do not directly access the last element, like in double linked list, etc. But searching the last element would take the worst case running time, right? So we should talk about the worst case running time or best case running time. Okay, we can compare the different implementation of array lists based on their time efficiency. What else? Time is a scarce resource for us. Actually, time means CPU time, right? CPU time is a scarce resource. We would like to use the CPU time very efficiently. Why? Because we do not have unlimited time and unlimited number of CPUs. It is limited. So we would like to use it efficiently. What else? What else is scarce in our systems?
Space efficiency.
Yes, another one is space efficiency. What kind of space? Memory space, right? Memory space is scarce. We do not have unlimited memory. So if a structure, data structure uses less space than the other, we can prefer it, right? If our space is limited. For example, in embedded systems, where the CPU is very limited, the memory is very limited, you have to be careful about them a lot. What about array list and linked list? Which one is better in terms of space efficiency?
Array list.
Why is it so? How can we measure the space efficiency? Probably we measure the space efficiency in terms of number of bytes, number of words, right? Or number of bits. Okay. The number of bytes in array list is less, you said. Why?
Because linked list uses more area.
For these links, right?
Yes,
for
for
these
these links. Yes.
It requires a little more space than direct array, since array uses just for the elements, the space for the elements, but the linked list uses for the links as well. You have to be careful about space efficiency and time efficiency for this structure. When you have to pick the right data structure to use in your applications, you have to be careful about these two. There are more, of course. For example, energy efficiency is important for these days as well. Why? Because you all know IoT, Internet of Things. There are very large amount of sensors around, and the sensors produce data, and this data usually processed in their production place besides the sensors, next to the sensors. And usually in that places, we do not have electricity running. We use batteries, and battery drains up very fast if you are not use energy efficiently. So energy efficiency is another concern that we should be careful about. In this class, we are going to talk about time efficiency a lot, sometimes in space efficiency, but we are not going to talk about energy efficiency much. None, probably. Okay, but that's also very important these days. Okay, is it clear? I didn't talk about the efficiency, time efficiency or space efficiency of these classes yet in detail. Give you some brief introduction only. But we are gonna talk about them a lot during these classes, and it's very important. The first is first implementation of list interfaces, array list. Array list uses simple arrays. Array is an index structure, as you all know. We usually draw an array like these, right? Several elements. And we can access by using its index, etc. Or we can access all the elements by using an subscript and incrementing it, right? In Java, arrays are fixed length, so you have to specify the length of the array. Then you create an array. That's an important limitation for the array list, since when you add new elements, the array can be filled up. There will not be enough space for the next element to insert in the structure. You have to be careful about. And when you have to insert in this position, all the elements after this position has to be shifted to the right. And when you delete this position, all the elements to the right again shifted to the left. These are three important limitations of the array structure, but we are going to use array by being aware of these limitations. If these limitations are not problem for you, of course you can use a structure, but you have to be careful about their performance if you insert in the middle or you delete from the middle of the list. The performance is less for these operations compared to linked list. In array, you can store primitive types and your class types, but in array list, you can only store class types, objects of classes. So you cannot store int or double objects in array list. You can store integer or double array elements in array list, and you can. These are wrappers for int and double. as you all know, and the casting between these are simple. As I said, ArrayList class is the simplest class that implements list interface. It improves the array and it doesn't get rid of these true limitations, but this limitation is not available in ArrayList. In ArrayList, when you add new element, you can always add a new element, and there is no limitation of the capacity. Capacity is increased when you add new elements. The advantage of the array list are in two. You can add or remove elements from the end of the list, and you can access randomly random elements, random indexes easily. So if you need these operations and you are going to use these operations a lot, then ArrayList would be your choice. But if you are going to insert and delete from the middle, probably you are not going to use ArrayList, since the performance of the ArrayList is worse than linked list for these operations. Let's see about the operations in the list interface and how you can use by using ArrayList. You can declare ArrayList, and this declaration is what? Generic declaration, right? Collection hierarchy uses generics. Means when you declare an array list or any other data structure in collection hierarchy, you have to specify the type of the objects. For example, here we have array list of strings. So here we create an array list of strings and store in this variable of type list of strings. As you all know, this is interface type, this is concrete class type, right? And that's possible. When you create a new array list, by default, Java creates an array list of 10 elements, limited capacity. But when you keep inserting new elements, and if you insert more than 10 elements, the capacity will be extended automatically. You do not need to worry about it. Okay, here how we add new elements in the array list. Add method is used, and a string is a parameter for the add method, since our array list is a string list, right? So we add strings, and this add method with one parameter adds the element at the end of the list. So we, after that 4 insertions, we are going to have this kind of list structure. Then we have, if we use this add with 2 parameters, the second one is of type string, the first one is an integer, first one is the index. In second position here, the doc will be inserted. So these 2 elements will be shifted, and a position is reserved for dark and it is inserted in the middle. After the insertion, the indexes of jumpy and happy is changed, as you see, right? Since they are shifted from position to the right. Okay, if you add dupi again, it will be inserted at the end. Since one parameter add method just adds at the end. Remove, you have to specify the index. For example, this is going to be removed. So everything here will be shifted to the left, and we are going to have this structure. Again, the indexes of these elements are changed, as you see. Okay, we can set by specifying index and element. Second value is set by new value. And we are going to see that the set returns this jumpy as a return value, but for the time being, let's skip it. Okay, we have get method. When we get the second index, it will return sneezy, right? So dwarf will be pointing to sneezy. And we have index of, as I say, we give an element and it returns the index of sneezy, which is 2. When we look for jumpy by using index of, it will return -1 since it is not available in the in this array list. Okay, generic collection or generics is what we used here. It creates a list of strings, etc. String is a type parameter. You all know these, right? You all know generics, right? Okay. This is a general structure for declaring creating a data structure using generics. Class name and E is the type of the elements, right? It's a type parameter. Of course, the type should match. For example, if we generate an array list of integer, and if we try to add a string into that array list, we are going to get an error message. In previous versions of Java, all these generics were not available. Generic collection, generic structure is not available. These are not available. So all this hierarchy, where is my hierarchy? Yes, this hierarchy is implemented but not by generics. Of course, it's not available, but using object class. Remember, everything is inherited from object class, right? So all these keeps the elements which of type object, not generic. That's also possible, but in current versions of Java, we have generic. If you use object class, then implementing these concrete classes, and of course, this interface, or collection hierarchy actually. If you use object class, you have to convert it to correct class. You have to downcast from object, then you need to access the value. And type checking was loose, but by using generic collections, better type checking is implemented in Java. In current Java, generic collections are available. You all know it, right? What is the counterpart of generic in C++? In C++, we have templates, right? Templates in C++ is similar to generic, right? You all know that. Of course, we are not going to talk about much on C++, but you have to remember. Okay, these are the methods that we have mentioned. Actually, these methods are declared in list interface, and they are implemented by ArrayList, since ArrayList implements the list interface. You all know these methods. We have already talked about these methods. The only thing here important is remove returns the element that is removed. Get returns the element, of course, that has to be like that. And the set returns the element, the previous element in that position before the set operation. Okay, the rest is simple. And add returns any Boolean value, whether the add is successful or not. Okay, here we have some simple application with ArrayList. I'm not going to go into detail, but here, as you see, this is regular arrays to some of the integers, right? Here, no. We have an integer array here, and we declare an array list and put all the elements in this simple array into array list one by one here by using add method. And here we get the elements one by one by using this index loop and sum them up. Okay, here, as I said, the num array is of type int, but array list is of type integer. So we need to have a casting here, and it is automatically done for you. It's wrapped, the int object is wrapped by integer object for you automatically. This is another application, simple application, a directory entries classes generated a name and number are two members. You can declare an array list of type directory entry. Okay. As you see here, yeah. What's the difference between having list variable or array list variable? What's the difference between them? The variable, we put the new reference of new array list, could be of type array list or list as in here, right? What's the difference between them? Come on, that's the end of our first hour. After this, after your answer, we are gonna have a break. Come on.
The variable is instance created as array list, so no difference. Type may be different, but the object are same.
The objects are same, but using this mylist to access array list and using this sumInts to access the array list, is there any difference? There is a difference.
If we use list reference, we cannot call the array lists special methods.
Okay, that's right. So array list implements the list interface, right? This is the array list. This is the list. Array list implements the list interface, but it can have some extra methods here, right? And these methods could be public as well. If we have an array list variable to reference the array list you created, then these methods can be used. But if you use list here instead of array list, you cannot use these methods specialized to array list. Okay, that's the difference that you should be careful about. So this kind of declaration restricts ourselves while using array list to the list interface only. You can only use the methods in list interface. When you make a call to a method of this array list, you can use only the methods in the list interface. Okay, that's it for the time being. Let me stop recording.